Welcome everyone to the launch of Low Carbon Learning, the programme which aims to support the industry towards achieving net zero built environment. The launch today aims to provide you with an understanding of what we will achieve over the next year, why we are doing it, and how you can get involved and upskill in low carbon learning that will provide you with skills needed to help you reduce carbon emissions. My name is Katrina Jordan, Head of the Retrofit Programmes at Construction Scotland Innovation Centre. If you have any questions and anything in regards to this programme, please contact myself. To set the scene, if some of you are not aware, this is the Phase 2 programme continuing from Passivhaus in Practice, an upskilling project which was part of the National Transition Training Fund supported by the Scottish Funding Council to upskill and reskill in Passivhaus standards. This Phase 2, which is supported by the National Transition Training Fund, will not only continue to upskill in Passivhaus standards and enable participants to gain certification in some areas, we will also introduce training in Retrofit and EnerPhit standards. The desire to upskill in low carbon construction has never been more relevant. Over the coming months, we will be offering fully funded training in Passivhaus tradesperson training delivered by AECB WARM, EnerPhit training, which will be their first ever training in EnerPhit by WARM, the Retrofit coordinator training and domestic retrofit training delivered by the Retrofit Academy. Supporting this online training, we'll also be creating immersive learning modules in Retrofit in collaboration with John Gilbert Architects, Glasgow School of Art. And something we are doing which we haven't done before is bringing the Passivhaus standards to institutes throughout Scotland through creation of mobile rigs. We will finally run a webinar series delivering webinars on low carbon learning covering a different topic each month. Why are we doing this? We have experts today to help define this. Sarah Lewis from the Pacifiers Trust, Sally Goodber from WARM and Duncan Smith from Renfrewshire Council. Before I hand over to Sarah, our first speaker, I just want to cover some housekeeping. If you want to ask a question, please click on the question icon and post it there, and we will answer it at the end of all the presentations in our question and answer section. The webinar is going to be recorded and the link will be posted on the social network channels. Finally, there'll be some polls throughout the webinar which we're really keen for you to participate in, and after the webinar we'll have an evaluation form. Please complete it as it helps us in providing the best service that we can. And here we just want to show you a short video capturing our project. And here is our first poll. On a scale of 1 to 5, what is your level of knowledge of Passivhaus and or EnerPhit retrofit standards in the built environment? The 1 being no knowledge and 5 being expert. You just select one and then submit your answer. We should get the results in a few minutes, a few seconds even. So we have a sort of general understanding, which is brilliant, and then maybe a little bit of understanding. So that's really, really excellent. We hope to increase that as the months go on. Sarah is an architect and a passive house consultant who has been involved in the development of some of the UK's largest passive house schemes. More recently, the first UK school aiming for EnerPhit certification. As a keen advocate for passive house and equipped with wealth of knowledge and expertise in the field, Sarah is also a published author of the best-selling book PHPP Illustrated, a complete user guide to the passive house planning package. In recognition of her contribution to low energy architecture throughout her career, Sarah also holds achievements including the 2018 European Sustainability and Environmental Women of the Year. Thanks, Sarah, and thank you for joining us this morning.
Thank you very much, Katrina. Let me just share my screen.
I'll leave you to it.
Just rearrange my screen so I can see everything. Great, super. Hello. So my name's Sarah Lewis. I am Research and Policy Director at the Pacifiers Trust, and it is so great to have so many people joining us today. This really shows the drive in Scotland for us to address this vitally important topic. But it's an early start this morning, and I ask you all to do some work first. So take a moment before we start and close your eyes. Take a moment to imagine. Imagine a Scotland where nobody lives in fuel poverty, where nobody returns home at the end of the day to a cold and mouldy house, where our vulnerable members of society are not at risk of dying from living in cold homes in the winter or homes which overheat in summer, where everybody has a warm, comfortable place to live, where people work and are educated in spaces with healthy indoor air that support productivity and learning, where our homes and public buildings support the transition to a zero energy grid and are part of the solution to the climate change emergency. So let's start talking about how we make that our reality today. So yesterday, the Passivhaus Trust launched 2 new publications, the first setting out our position on retrofit in the UK, and a second, which is a new tool for the Passivhaus software to assist in accurately calculating energy use in existing buildings. These, we can send out links to everybody who's on the call today and registered. So my presentation is going to look at how the sort of passive house retrofit standard fits into net zero, and I'll also cover the range of EnerPhit options. I'm just putting my timer on because I realize otherwise I'll not stick to time. So I'm going to talk through why retrofit is important, how deep do we need to go when we're looking at retrofit, what does EnerPhit deliver. I'm going to talk a little bit about the EnerPhit informed retrofit plan. I'll look at those EnerPhit options, and then we'll finish with our recommended approach to EnerPhit projects. So while my presentation today is very much going to focus on the energy reduction and health improvements possible through retrofit, I do think it's really important mentioning the huge embodied carbon saving delivered by retrofitting rather than rebuilding. And we must be responsible with our finite resources and always think retrofit first. And this ties into my first point, which is displayed in this slide. We all know that our energy grid in the UK is gradually decarbonising. So in time, there'll be very low emissions from buildings using that grid without, significant energy efficiency improvements. So you do often hear this argument using this logic that retrofitting our buildings is not necessary really to reach net zero, and we can just wait for our grid to decarbonise. However, this could be a very dangerous assumption without considering the bigger picture. So whilst the energy offered by wind, solar, tide does indeed exceed our energy needs, our capacity to harvest that energy is not infinite. There's a financial and carbon cost for all renewable technology. So there's a limit to how much renewable energy we're going to have in the future. This graph shows that by saving energy through building more efficiently, it's cheaper than creating a different additional renewable energy. So investing in our fabric efficiency makes financial sense. It's effectively cheaper to save a kilowatt than to generate a kilowatt. And the total amount of renewable energy that we're just discussing that we can generate over the course of a year is important, but that's actually not the only issue. And actually a bigger issue is the peak load that the national grid is able to deliver now and also in the future. So it's estimated that the peak thermal load currently demanded by our homes and delivered by gas is about 170 gigawatts. You can see that on this graph with the orange and the turquoise bar. And the current electricity grid capacity is around 60 gigawatts. And even by 2050, it's only projected to be increasing to around 100 gigawatts. And at the same time as looking at the whole grid, we have to remember that it's not all for us. All sectors, particularly transport, will be transitioning to draw their energy from the grid. And so our renewable energy sources need to cater for all their demands as well. So we have to really think carefully about how much we really can allocate to our buildings. And this graph shows two future peak load scenarios. The first is looking at existing homes switching from gas to electricity without any demand reduction. So it's that argument, we'll just wait for the grid to decarbonize. But you can see that the additional peak heating load is 15 kilowatts per home, and that totals 125 gigawatts, and that's more than the grid is going to be able to deliver. The second scenario says actually we're going to give all our homes a deep energy retrofit and reduce their demand at peak times, and this results in a much smaller additional peak load of only 5 kilowatts per home. So this clearly demonstrates that demand reduction is absolutely essential to enable us to achieve a net zero balance in the UK. So the question is, how far do we need to go? I know that Duncan, who's speaking after me, is going to talk about the overall sort of carbon picture, so I won't mention that. And I've covered the grid capacity, but what are some of the other factors that we've got to consider? Retrofitting a heat pump into an existing building is by no means straightforward. Heating systems are designed to operate with gas boilers and work at high flow temperatures, whilst heat pumps tend to work more efficiently at low temperatures. So making a building suitable for a heat pump usually involves some sort of demand reduction, so some sort of retrofit, combined with things like going in and increasing the size of the radiators. And as I mentioned, it's more cost effective to save the money than to generate it. But maybe the bigger thing to think about is that poor quality homes have a hugely detrimental impact on our health. Many of our existing dwellings are too cold in winter, too hot in summer, and suffer from this poor indoor air quality. And these issues really impact our health and well-being and affect, in particular, the young and elderly and those with respiratory conditions or compromised immune systems. The BRE did a report that estimated that poor housing costs the NHS about, I think it was something like 1.4 billion every year. And the Pacifiers Trust, we're going to be publishing a benefits guide later this year, which will have more sort of detail and figures on that kind of topic. So fuel poverty is obviously a really critical issue too, and I think Duncan's got some good figures on the Scottish levels of fuel poverty. There are across the country, the whole of the UK, about 3.3 I think it is million homes who are currently in fuel poverty, and that is likely to increase with this continuing energy market volatility that we have and we're seeing play out around us. So our efforts to achieve net zero can't make this worse. They shouldn't make this worse. Electricity is still much more expensive than gas. So getting this switch to zero carbon heating wrong would not only push more people into fuel poverty, but would discourage any large scale take up of heat pumps from the general public. And then finally, retrofit plans can be integrated into existing asset management plans and provide future added value for large public sector clients. So this future value may be through occupant health, capital value, the increase in capital value, or kind of wider social value. And the appraisal of social value is based on these principles and ideas of welfare economics and concerns overall social welfare efficiency, not simply economic market efficiency. I don't know if anybody saw the REBA 2021 Built for the Environment report. I think it came out last week, but it really highlighted the importance of this approach, moving away from decisions dominated by capital cost and understanding and adopting instead this whole life costing model. And by adopting these principles, we can improve the quality of life, deliver more homes, and retain cultural heritage and community ties. and avoid this really carbon intensive and costly demolition and rebuild process. So overall, these arguments would suggest that achieving this net zero, enabling heat pumps, improving health, and realizing these broader societal benefits are most likely to be achieved with a really deep level of retrofit, which results in significant energy demand reduction. Shallow retrofits put building owners at risk of possessing stranded assets as a result of carbon lock-in. And there's a risk that these shallow measures are then not part of a whole building plan, which will result in unintended consequences, including issues around moisture and condensation, issues which can effectively exacerbate health risks and issues rather than solving them. And I find I like to include this slide when I talk about retrofit. So I find this slide slightly terrifying and exciting in equal measure. On my more pessimistic days, the knowledge of the sheer quantity of retrofits required to get through all 28 million homes in the UK is quite paralysing. We need to be completing a retrofit every 35 seconds or have 500,000 simultaneous retrofits going on around the UK continuously from now until 2050. But then the optimist in me sees the huge opportunity this brings, growth in the retrofit industry to deliver all these projects, and then just the absolute monumental positive impact it will have on the lives of people around the UK. It's climate action, which is not asking people to make sacrifices, but it's climate action, which when done correctly, provides only benefits for the people it touches. So we're going to talk a little bit about the Passivhaus EnerPhit standard, and when we're looking at any energy standard, we talk about the space heat demand because that is a very good proxy for a building's fabric performance. So the Passivhaus Trust have been working with the Letty Group to build a stock model of the UK's existing domestic buildings, which has been used to model the space heating demand profile for our current homes, and it's broken down by building form. So this model reveals that the average UK space heating demand you can see is around, I don't know, like 120 to 130 kilowatt hours per metre squared per year. And a typical new build in the UK is coming in at around 85 kilowatt hours per metre squared per year once you take into account the performance gap. Which is interesting to note then that our new homes are going to need to be retrofitted as well by 2050, but that's for another presentation. The EnerPhit target you can see there is down at about 25 kilowatt hours per metre squared per annum. So for an average home to get from where it is to EnerPhit levels, we're talking about an 80% reduction in space heat demand through fabric improvements. So this table and the one on the next slide are actually from our position paper. The table compares the EnerPhit standard, so the Passivhaus retrofit standard, to the AECB standard, which is another well-recognised UK low energy retrofit standard. And it focuses on how these standards deliver energy and emission reductions, how they improve comfort and health, and how they close the performance gap. As I mentioned on the previous slide, the space heating demand is this good proxy for fabric performance. So just looking at that metric for a second, the Letty guidance, which is coming out later this year, provides a limit for space heating demand of 50 kilowatt hours per metre squared per annum. And then there's going to be this exemplar target of 25 kilowatts. So these values coincide perfectly with the AECB standard at 50 kilowatts and the EnerPhit standard at 25. So as I said, we must recognise with the sheer quantity of buildings needing retrofitted, we're unlikely to be able to reach every single home by 2050. Therefore, there's going to remain this cohort of buildings with poor fabric performance, which need to therefore be compensated by those buildings that are able to reduce their demand to EnerPhit levels, so that exemplar level. And EnerPhit's providing us with that target. It's giving us a route to getting to that exemplar level of performance. The other really important thing to think about is the performance gap. We know in new build homes what this is. It's well documented, and a conservative estimate is 60% additional space heating demand from what is calculated at design stage. And if anything, the retrofit performance gap is likely to be even more significant because we've got all the same root causes and there's even less regulation. So that's certainly a concerning thing that we've got to think about when we're doing retrofit projects. And the Passivhaus approach has been shown to effectively close the energy performance gap using this combination of rigorous design, demanding criteria, and the independent certification process. And this is the critical element of the EnerPhit standard, which sets it apart from other standards, this independent certification. It's a little unfair for me to actually have LETI on this table, as LETI are simply offering guidance to support a good level of retrofit, but I've included this just to show you that having guidance is not enough. And for this reason, LETI strongly recommends that a recognised retrofit standard such as EnerPhit or ACB and a full quality assurance process, which is provided with the EnerPhit standard, is used alongside the LETI guidance. So I'm not going to spend long on this slide, but I just wanted to include this to recommend that you all interrogate this in our paper when you have time. This table acknowledges that all approaches require some augmentation to deliver fully robust solutions addressing all the possible unintended consequences. So we're going to be going into these topics in detail through the training that Sally is going to be talking about later. And as the previous slide, it's important to note that the LETI guidance needs to be used alongside other recognised standards and quality assurance processes. So achieving this full range of desired outcomes and their associated benefits is clearly essential, and anything else is just a missed opportunity. So taking all these factors into consideration, the Passivhaus Trust is recommending that an EnerPhit-informed retrofit plan is created for all retrofit projects. And this will create a whole building retrofit plan that allows all retrofits to benefit from the distinct advantages of the EnerPhit methodology, including modelling the existing building in the Passivhaus planning package, to provide detailed calculations of the existing fabric performance of the building. And that provides you with a really good base from which various different upgrade options, including a range of different energy performance targets, can be tested as part of this kind of options evaluation process, which and that forms part of the PASS 2035 process. So you can use the EnerPhit plan to deliver a project to that standard or to that guidance. So yes, where projects obviously adopt the full EnerPhit standard, they're also going to benefit from this performance assurance, which is provided by the EnerPhit certification process, which we recommend. So our paper gives details or goes into a lot of detail for each of the EnerPhit approaches, and I've not got time to set all this out in detail today, but I'm very happy to take questions or expand on anything during the Q&A session we've got. So I'll just briefly explain. There's two main approaches to reaching an EnerPhit project. A space demand method and a space heating demand method and a component method. And then there is a step-by-step delivery method, which can be used with either the space heat demand method or the component method. So a single stage heat demand approach covers all projects where you're going to carry out all the retrofit work as a single project, and the outcome is that the space heating demand is reduced to that number that we were talking about earlier, the 25 kilotowers per meter squared per annum, along with various other certification criteria, just to make sure that we're maximizing health and well-being and comfort. And I included this slide because this was a pilot project I worked on in 2011 when I was working at Bear Architects, and it shows that deep energy retrofits aiming for the EnerPhit standard are not a new idea in the UK. It's just that we've now got to really ramp up the delivery. And I included this slide as it's a good one just to show the range of typologies and locations of projects that have been aiming for EnerPhit as a single stage project around the UK. So we've got a project there from Manchester, one from Glasgow and one from Portsmouth. And you can see the scale of those buildings as well, showing you a range of different typologies. So it's applicable to any building you can think of. And then, as I was saying, there's the second approach, and the second approach is called the component approach. And this doesn't refer to Passivhaus like individual components, it refers to component parts that make up a building. And the reason that this option exists is to cater for buildings where the orientation or form of the existing building or the glazing ratio, which you can't change in a retrofit, preclude it from ever reaching the 25 kilotowers per meter squared per annum, even once you've done all the upgrades to the Passivhaus sort of levels of fabric performance. So this typically results in a space heating demand somewhere in the region of sort of 30 to 40 kilowatt hours per meter squared per annum, so slightly higher than the heat demand method. But again, what's so important is that it's following the Passivhaus standard, which makes sure that we eliminate the performance gap and we maximize health and well-being for residents. So there are various reasons that it might not be practical to deliver an EnerPhit project in single stage, which is why the Passivhaus Institute launched this step-by-step approach back in 2016. And this can be used with either of the two approaches I just outlined, so the energy demand or the component approach. And it's a given, obviously, that in time, different parts of the building components of an existing building will need to be replaced, but not all at the same time, but as they reach the end of their lifespans. And this approach ensures that we don't just replace these old building components, with similar poor quality components, but whilst the opportunity is present, we improve their efficiency to EnerPhit levels and in turn prevent locking in poor performance. And the aim of this approach is to allow individual retrofit measures to be implemented over an agreed period of time, which may be years or even decades. And for this approach to be successful, a full overview of the project from the start to completion must be undertaken, because this ensures that the high levels of energy efficiency are achieved, and at the same time it's done in a cost optimal way. And it also makes sure that the project avoids unintended consequences by, again, incorporating that certification process. So I'm just about at the end now. I realize I've gone slightly over. So this flow chart is included again within our position paper. Hopefully you can read it on your screens. I'll just briefly highlight some bits to you. So all retrofits need to start by modelling and investigating the existing building. And then findings from this work can be used to create an EnerPhit informed retrofit plan, which must include an appraisal of social value on whole life costing. If the outcome of this work shows that the client can support a single stage EnerPhit, super, it's full steam ahead. But for those projects which can, one step at a time might just be the answer, with a step-by-step EnerPhit over a number of years. If the heat demand method cannot be achieved for the building, then the component EnerPhit approach can be used. And again, this can be a single stage project or a step-by-step phased project. And finally, if none of the EnerPhit approaches can be delivered, then we recommend an alternative standard is used, such as the AECB standard, or you follow the LETI guidance, but with appropriate bolt-on extra criteria and a Q&A process to eliminate the performance gap and the unintended consequences. So I think I'm at like my last slide now. So at the moment, we're just finalizing some graphic primers at the Pacifiers Trust. So I thought I'd put those up so you can see what's coming soon. But those are to help make the research that we've been doing around zero carbon and retrofit more accessible and approachable. So they should be out in the next couple of months. And then in November at the UK Passivhaus conference, we're going to be launching our benefits guide, which is a wide-ranging piece of work exploring the co-benefits of Passivhaus and EnerPhit. And then later this year, we'll be part of the launch event for this new LETI retrofit guide, where we're one of the authors and supporting organisations. And finally, our main research topic for next year is the research on retrofit costs, which we recently started with Faithful and Gold. So I'm going to leave it there. Sorry for running slightly over, and I'm now going to pass over to Katrina, who I think is going to put up a video from Duncan Smith.
Thank you so much, Sarah, for that fantastic presentation, and it really sets the scene and what the drive for deep retrofit and the importance of that. So we have a recording from Duncan which we're going to play, and then Duncan will join us for the question and answers. And just also, if you have any questions for Sarah, please post them in the chat, and we'll have an opportunity at the end to have a real discussion about any of the topics that we've discussed. Duncan Smith has over 30 years experience in construction and energy industry, working with both public and private sectors in the UK, Europe and Australia. He has worked with a number of companies, including Scottish Power, Clark Contracts and Persimmon Homes, and several local authorities, including ones in Sydney, Falkirk and Renfrewshire Council, where he currently is. And Danielle, if you're able to play his video, that would be excellent. Thank you.
Hi, I'm Duncan Smith. I'm the Housing Asset and Energy Strategy Manager at Renfrewshire Council. Just want to thank Katrina for inviting me along today to talk about social housing and retrofit, particularly deep retrofit, on a pathway for EnerPhit and how we can achieve a sort of net zero standard and the benefits that can bring both for contractors as well as for housing associations and local authorities. But before I do that, I just want to set the scene in terms of climate change and the importance of the built environment and how we reduce our climate emissions as per the Paris Agreement in 2015. We've got COP26 coming up here in Glasgow in just over a month, and I want to frame the importance of housing in relation to that and how we meet our collective challenge. And some context here in the UK, about 14% of all emissions are as a direct result of how we heat and provide hot water within our residential homes, and it's actually more than the emissions from cars. So housing is crucial in how we make the transition to becoming a zero carbon economy and how we meet those climate change targets. But how do we manage that transition? That's the question we have from a social housing perspective, such as electrifying heat. How do we manage that transition in a way that's sustainable, not just for the environment, but for our tenants in a social housing setting? Well, if you hang about, hopefully I'll be able to tell you. So housing in Scotland, in particular social housing, makes up around 25% of all of our homes. It's a little bit more than the overall UK and English figure. But we've got quite an old housing stock compared to most European countries. And about 30% of our homes in Scotland were built before the end of the last war, so getting on for 70, 80 years old in many occasions, actually more than that. And a lot of those homes are of solid brick or concrete construction or no fines or traditional sandstone, so already in the sort of hard to treat bracket. About a third of our homes are flatted, again significantly higher than the average UK figure. And this is again higher in the social rented sector. So we've got problems with age, problems with the age of our homes, issues with the construction and the materials that were used when they were built, and big issues with the tenure of our stock in terms of mixed tenure, where we have to engage and take owners along with us in order to improve housing stock. So with these physical issues in mind about the age and type and construction of our homes, what do we spend on energy? What's the social side of the energy debate? Well, we spend as a nation about 2.6 billion a year, and this is based on publicly available data from the Scottish Government. And that equates to a sort of eye-watering 25 billion if things continue over the next 10 years. A significant amount of household spend is spent on energy costs. Now, this includes domestic electricity. It's not all domestic heating, but a significant proportion of that, about 2/3 to 3/4, will be. On average, that figure is about £1,200, £1,250 a year, and this figure is actually already out of date. There are significant changes in the market, and there will be from the 1st of October onwards. So, you know, a lot of money per household being spent on energy. Within a social housing context, we think that's nearer £1,700, sometimes as much as £2,200. And that's from our own experience as a landlord, as well as work that's been done across the wider sector from various agencies. As a result, 25% of Scots are in fuel poverty across all tenures, but quite alarmingly, that figure is 38% across social landlords. So, you know, almost 40%, like there's pre-pandemic figures here, so I'd imagine that this will have increased, but that's over 600,000 households living in fuel poverty out of a population of about, or a household population of about 2.5 million in Scotland. So, you know, bear these figures in mind when you're challenged on the affordability of deep retrofit, either by clients or consumers. I think sometimes we tend to look at what we pay for energy as some sort of fixed taxation. It doesn't have to be, and I would just bear these costs in mind, and perhaps even look at your own utility bill tonight when you go home and map that over 10 years and tell me what your household will be spending. So in terms of, again, go back to climate change and what we're going to have to do in order to decarbonise our country, the main thing really is the electrification of heat and transport. We don't really think that hydrogen will play a part for domestic heating. It will be important for other sectors, in particular, or possibly transport, but more likely things like chemical engineering. But the energy transition, mainly from a domestic heating perspective, will be about the electrification of heat, how we supply low carbon heating networks, how we supply heat pumps, both communal and individual. But there's a huge challenge in terms of the sheer volume of kilowatt hours that have to be swapped over from gas to electricity, and that will inevitably mean that we'll have to look at infrastructure upgrades both within the network and also capacity to meet the demand, to switch away the 28,000 gigawatt hours of gas to electricity. So increased electricity generating capacity and increased network capacity to deliver that energy to your door. So from a social housing, from a social landlord's perspective, what are the considerations about the stock that we have and the transition that we'll have to make? Well, a higher proportion of our households are single households, and a higher proportion again are older and single households on fixed and limited incomes, and that puts them at risk of fuel poverty and indeed extreme fuel poverty. Tenants tend to be at home more often and therefore require more heat. You know, everyone knows the longer you're in a home, the more heat or the higher temperature that you require, your sort of body gets used to it. The DLG estimate that about 63% of tenants, this is across the UK, not just Scotland, are in receipt of local housing allowance. So that gives you again some context in terms of the affordability and the agency that people can exercise in terms of their finances. But crucially, the cost of electricity is around 3 to 4 times the price of gas, and that's a very important point here just now, because the majority of social rented homes, majority of Scottish homes are powered for heating using gas. I think the figure's about 78% in total. So we have to bear that in mind given these complexities around the social side of housing. But as I've said earlier, the figure is 37% officially, but I think that's probably north of 40% now. 40% of tenants are in fuel poverty. Now, the question I would ask is gas sustainable at the current stage? Never mind the transition to the electrification of heat. So these are the things that we have to think about and plan into how we transition to renewable heating and how we do that in a way that doesn't make our homes unsustainable. So given the nature of the stock that we have as social landlords, of the 600,000 socially rented homes in Scotland, given the difficulties we have with the type of property, the age, the construction, mixed tenure issues, given the social issues that exist within social housing, people on limited and fixed incomes, a significant proportion of people at home more often and don't have access to the same revenue income streams than perhaps private rented homes. The question we would ask is, what is a sustainable social housing product from a retrofit and energy perspective? What does that look like and what should we be thinking about? Well, for me, that's a fabric first approach, and I think it probably won't shock anyone in terms of our strategy. We think that we have to look at reducing the energy demand within our housing stock. About 80% of the homes that we'll be using in 2050 have already been built. So the issue for us is less about new build, more about what we have just now and how we make that sustainable. So need to reduce that demand within our housing stock to lower fuel bills and reduce carbon emissions. It's a dual process here. And you can only really do that with a focus in fabric first. But fabric first is often misused or misunderstood, and there's a trio of things that we have to do around fabric first. It's about the good application of insulation, mitigation of thermal bridges, increased air tightness measures, and fundamentally mechanical ventilation. So, you know, we have to look at the fabric first approach through a much more sophisticated lens than perhaps others have been to date. And crucially, this approach allows the transition to renewables, either low carbon heat networks or individual or small scale common heat pumps, in a way that's viable, in a way that protects tenants from increased energy costs. So what does that physically look like? Well, you can see here some of the pictures that we've taken over the last year and a half or so. And a fabric first approach on a two-stage EnerPhit journey is about looking at an external approach that complies in principle with EnerPhit, and that's about reducing that demand from what you can do externally. It's also about providing renewables where that's appropriate and you can see here some of the slides that we have. Now, I've highlighted these properties in particular because they're all built around the 1920s and 1930s, and I think they look fantastic, but it gives you an idea both what can be done from a performance perspective, cautious of using SAP, but these all now score SAP A, which is comparable in terms of what new build is in the local area. But aesthetically as well, from an estate regeneration perspective, I think the aesthetics look excellent, and you're taking things further, not just from an energy perspective, but from a communities and building neighbourhoods perspective. So these properties all built around 1929 on the left-hand side, I think 1929, to 1936 and the right-hand side there. And this is what a fabric first approach looks like. I'm happy to discuss the details and the minutiae of the specification, but it's about mitigating thermal bridging, good application of external insulation, balanced boundary conditions, as well as choosing products and processes that will extend the life of the building. And again, just some pictures from other local estates, just to give you an idea of the type of product that we're delivering. I think we think that far too often housing is looked at as a sort of singular industry, and I think what we would like to try and convey today is an opportunity for social landlords to contribute to some of the challenges that we have, but also address some of the fundamental issues that we deal with on a day-to-day basis. And good quality retrofit towards EnerPhit or comparable standards has a fantastic opportunity to build a much more sustainable construction sector, a much more sustainable economic recovery in terms of higher skilled workers working to processes and standards that in turn will benefit the health and well-being of the residents within them, which will in turn reduce poverty and fuel poverty, also lessen the burden on the NHS, and collectively meet our climate change targets. So there's a sort of cycle here that we want to convey to you, and the opportunity around deep retrofit, high quality retrofit, sophisticated techniques and practices towards reducing demand, and how we can then encapsulate that within a whole systems approach. And that's me. I can say thanks for listening, and again to Katrina, thanks for inviting me on. Hope to take some questions along with the other members at the end of the session.
I hope you agree with me that that was really a great presentation, and putting it into the Scottish perspective, and particularly the social housing aspects. And we can ask Duncan some questions shortly. And Duncan and his team are really leading the way in Scotland for deep retrofit. We've had some great insights into the benefits of retrofit this morning, and the wider impact and the reduction of carbon, and how EnerPhit is the way to achieve low carbon buildings and driving the way we construct with care. Just moving on to our next poll, and then I'll introduce Sally. Where within the built environment do you feel low carbon learning, upskilling is most required? Within the construction, design, policy and standards, or building services? I'm wondering, will that be evenly spaced across the board? And we're not far away from it, so yeah, basically we're looking at all areas of within the built environment that we need to upskill in. So Sally is the director of WARM, the low energy practice, and a chartered mechanical engineer, Passivhaus certifier, and a member of the UK technical panel, reporting to the Passivhaus Institute in Germany. She has a vast experience in design and construction of low energy residential and commercial buildings, as well as building services. And she's recently completed her own certified passive house, and is also completing a stepwise EnerPhit of a cafe and holiday home. So thank you, Sally, for joining us this morning.
Hi, Katrina. How
Hi
are you
there.
doing?
Brilliant. Thank you. I'll
Made it
leave you
work.
to it.
Yeah, bro. Okay,
Thank you.
so I'm just wondering, where do I get the? Here we go. Okay, I'm just trying to make right. Okay, can you see that? Is that okay? Can you
Yep,
let me
we
know?
can
Is
see it.
that you can see the
Perfect.
screen? Yay! Great start to the session. Thanks so much. So as well as working at Warm, I'm also one of the trainers and managers of the AECB Carbon Light Passivhaus training, and that's what I want to talk to you about today. So we've been working with Construction Innovation Scotland to provide some of the training, and particularly around kind of Passivhaus contractor training, which, as we've just been talking about, is kind of a particular area where we think that we need kind of higher skill level. So I'm just going to talk to you about kind of what the course entails and how it kind of fits into the whole scheme of kind of what we need in terms of the greater skills. So the course that we're proposing, that we're putting forward, is it's an introduction to the theory and practical implementation of the Passivhaus standard, and it's aimed at people that are working in the construction side of things as opposed to on the design side. And it goes through roughly what a passive house building is, how it's different from other buildings, the approach to design and construction, and common passive house vocabulary, and also the process, including certification. Now, that is that's kind of all really important stuff for everyone to understand in terms of kind of low energy buildings going forward. But the real kind of nub of what we're trying to do is provide the real kind of practical experience. And it's all very well us having lovely designs and modelling, demonstrating kind of huge performance improvements or whatever else. What we actually need is real buildings that do it. And this is what this course is really about. And the mainstay, the kind of the most important part of all of this is these guys, the people on the screen, because the training that we're providing is all delivered by people that have really done it. And that's the important part of all of it, is giving you that real experience of what went wrong, how to fix it next time, and advice in terms of kind of managing the process, and just the kind of real experience of having done it, having been through it. And that's the kind of the most important bit in terms of the training from our perspective, is that it's delivered by practitioners and particularly kind of specialists that have really done it. In terms of benefits, the first thing is in terms of it, it means that from coming on the course, you've got a really good understanding about what it is, and you can talk to clients and designers and everyone else within the field and understand what exactly is going. You can kind of talk to them in the same language. And also being able to identify risks and opportunity, and can look at a design and determine how easy it is to meet the standard, where the risks are, what kind of is going to need to be implemented to ensure that you're going to achieve a successful project at the end of the day. Also to be able to understand the implications to the program and sequencing, and this is particularly important when you're thinking about kind of what we need to deploy, also in terms of engagement with subcontractors, and also being able to plan for kind of management strategies on site. Really having a kind of detailed understanding and being able to interrogate and understand what's the expectation. And to make sensible suggestions for product replacement. We're doing some training yesterday for a similar course, and it was really interesting talking about the feedback from the contractors in terms of the relationship between when products are replaced and understanding the full implications of making those changes. And this was a really key part for us, is saying, well, you know, kind of, we really want you to deeply understand and be able to make suggestions that are really, you know, that they're valid and they're not going to negatively impact on the building performance. And having a whole team that understand the standard and a real sense of kind of working together towards a common goal is really important. Rather than relying on a couple of experts, it means that then there is a kind of collective understanding, and it becomes kind of embedded within your organisation. I think this is really key part of the whole picture, is that rather than this being that it's kind of all in a black box and we're not sharing our knowledge with you, it's that we really want it to become integral to what you do, so that then we can kind of optimize it, get it down to so that it's low risk, it's low cost, and it's easy as a process. In terms of the course, there's several parts to it. The first part that we're offering is a theory session, which is 2 afternoon sessions, which is online, is live. So this means that I was talking about how important the trainers are in terms of the delivery of this. This means that the live sessions, you have kind of direct impact with them and are able to ask them questions, have discussions and whatever else. So far in the first tranche, we had about 120 delegates attended this, and it goes through lots of the kind of practical reality of achieving the standard. There's lots of interaction there. There's an expectation that you kind of, you need to come with your own questions about how to apply it in your particular scenario. Then the second, and here's some kind of typical examples of the kind of things that are talked about throughout that course. So here, this is going through where, Sarah was talking about the performance gap and the difference between the intention at kind of design and what's actually delivered. And so the aspects that make a difference on site in terms of that performance gap are kind of drilled in and really interrogated. And this is kind of an example of the kind of things that we'll be going through and the information we have. And this is really crucial, because it really, the idea is that we kind of skill up the team so that they can spot issues, so that they can identify problems, because things do happen. And here's a kind of classic example, just an example that we're using on the course, where there is, we have some insulated, it's an insulated sandwich panel construction with concrete on the outside. We're looking down at a wall construction, and the site team spotted that there was a thermal bridge going through. The concrete goes through this section here. And this was a really great example of the kind of things that are likely to creep up on site that have that negative impact. And so being able to show examples of the kind of things that happen, and then talk through how would you get around that, and what would you practically do, and how would you mitigate it in the future, gives people really solid tools to be able to take this forward. So that's the first part of the training, is kind of the online theory, which, as I said, is kind of 2 afternoon sessions. And it is aimed at both new build and retrofit. The kind of theory part of it is applicable to both. Then we have the second part of the course is a practical sessions, which is run at Construction Innovation Centre's centre. And we have a load of different example setups for you to be able to kind of really have a go at it. And this is really important for us to be able to benchmark and understand what good looks like, okay? Because that means, in terms of really getting to grips with what it's going to take on site to achieve that, over kind of large or small projects consistently, it means that kind of really seeing it for yourself is so much more important. And there's a variety of different things that we go through, from looking at specific products, having a go at doing it yourself, and kind of carrying out air tests and all of these kind of things to give you a kind of really rounded view of the whole thing. Now, because this is carried out in smaller groups, there was only about 45 delegates carried out this tasks, were able to book onto this. And there's a really high demand for coming and doing this. I'd say that it's really exceptional. So please, book quickly on that one. Then if you wanted to take it a step further and to become a certified Passivhaus tradesperson, which is a kind of an international qualification, then the training that we're providing in terms of the theory and the practical sessions are the basis for taking that forward. So the add-on for it is doing a revision session and an exam, and we have one of these which is free and funded through the Construction Innovation Centre, but you can also contact us separately for carrying this out independently. And it's about kind of being able to demonstrate that you've met the standard, and it's a great kind of marketing tool to be able to demonstrate that you understand the theory of meeting the standard. Now, this qualification, in terms of where it sits alongside the other passive house qualifications in terms of kind of people, the first one is we also have the kind of passive house designer qualification, and people are also certified as certifiers, or a lot of certification going on there. So in terms of the designer qualification, it's usually done by a 2-week training session. And then there is a long 3.5-hour exam at the end of it. So it's quite an intensive amount of training. It's quite a big commitment in terms of time. And it means that that person is then able to do the kind of PHPP modelling of the project going forward, and also provide design advice. It doesn't mean that they have designed a passive house in the past, and they may have very limited experience, but they have the theory part of it and the kind of the understanding to be able to apply it. In a similar way, the tradesperson qualification. Now, I think this is the wording on this isn't a great translation, to be honest, because I don't think that this is truly applicable to tradespeople. And you'll notice that the training, we've labelled it up as contractor training, because I think a lot of the kind of information that we're providing is much more about the kind of overall management and strategy and site management and team management, as opposed to necessarily someone that is carrying out the work, unless they are also doing some of that kind of oversee work as well. So it's 3 days of training. And it shows that there's a kind of an understanding. Having this qualification shows that you've got an understanding of the implications of passive house to the contractor. It doesn't mean that they've built a passive house in the past. So this is very much about having the kind of skills and everything else to be able to apply it, as opposed to demonstrating that they have built one. In addition to those 2 people, so the kind of the designer consultant is very much there to kind of with the technical knowledge to kind of make sure that the passive house stuff is kind of well embedded in the project. And then we have the kind of tradespeople or contractor training and qualification, which is there to ensure that it's well delivered on site. The other person in the puzzle, which is kind of an additional add-on, is the passive house certifier. And they are generally kind of specialists in their field, and they are there to provide the kind of quality assurance process for the project and sign it off to say that yes, it has met the passive house standard. There is also a retrofit course coming up, as Katrina said, and this is going to be coming soon, and the intention is that this is going to be a bolt-on to the contractor training that we're providing. So you need to go onto the kind of the core retrofit training that I've just been describing before you come onto this course. And that's really crucial, because a lot of the theory which applies to retrofit is carried out in the main course. And then we will be looking at retrofit solutions exactly like this, and kind of how to solve problems when you're on site and what to do to kind of make the project a success. So in terms of what's coming up, the training, we've got 4 online contractor training sessions. So that's the theory sessions, one running every other month, and there's about 30 delegates can book onto that each course. We've also got 4 practical days. As I said, there's already a demand from the previous sessions, and we have those are kind of 20 places each. So please, yeah, kind of get booking onto those as soon as you can. And then we're going to do one of the revision and the tradesperson qualifications through this funded program, and there's 20 places available for that. The retrofit course will be coming up in the next couple of months, and further information will be coming online about that. Cool, that's me done. So I'm going to hand over back to
Thanks so much, Sally. That was brilliant, and just setting the scene, and also it's really great to just explain what's actually been covered in the course, and then what we have up and coming. So I think hopefully that's that's given the participants a bit of an understanding. So we're just now, I think we're going to open up to some of the questions and answers. So Sarah, if you want to join us as well, that'd be great. And we have a couple of questions in the chat Danielle's posted for us. So one, Sarah's, I think particularly for you, from David, and he's asking, is there a guide to the EnerPhit, and how is it different? Sorry, the ERP, and how is that different? Yeah.
So the question relates to the Passivhaus EnerPhit standard. When you're delivering a project to that standard and using the step-by-step approach, you use something called the EnerPhit Retrofit Plan, which is where which gets called ERP. And that's used for projects that are following the step-by-step approach. So what we're saying is you should have this EnerPhit informed retrofit plan, regardless of what your end goal is on a project. So when you've got a new project that needs to be we're saying what you should do is you should analyze it in the Passivhaus planning package, so our design tool, to build a model, to sort of look at options using that flowchart we had, up to EnerPhit, and look at how you could achieve EnerPhit. But even if you can't, you still use, you're still planning with the kind of EnerPhit in an EnerPhit informed way. So rather than saying, well, we're not going to meet EnerPhit on this project, we're just going to not model it, we're just going to do like ad hoc little retrofit measures as and when we can. We're saying no, create a plan and use the EnerPhit process because it exists. It's a really good process. So even if you're not actually doing a step-by-step EnerPhit, use that process. So that's what we're calling EnerPhit informed. So it's for when, I suppose, when we're looking at retrofitting whole estates or whole like all the school estates or something, it might be that as I was explaining, we can't get everything to EnerPhit. So it might be that you're going to get 50% of your stock to the 50 kilowatts. There's maybe, I don't know, 25% that are going to fall below because they're really hard to treat. And then you've got that 25% you're going to have to put up at the top and meet EnerPhit. But for everything, create a plan, because then you've got a strategy set out. So hopefully that answers.
Yeah, definitely. I think that makes sense. Sorry. Go, Sarah.
Can I just add, because I think this is it's such a crucial topic about kind of how far do we go, and one of the problems is there isn't kind of conclusive because there's so little about where the grid is going to get to, all of the other factors that are kind of coming into this, so we don't know. So it's really important that we don't kind of build ourselves into a corner by putting measures in place that later down the line we have to retrofit and have to take off and redo. And a really classic example of that is external wall insulation, and we did some air testing on a whole raft of external wall insulation that was done for a local authority down here on some housing association. And because it had been so poorly thought out, because they didn't have that retrofit plan, and even though they were only carrying out one measure, that one measure that they carried out, because it wasn't part of a kind of process where they hadn't thought through the long-term implications of it, it had no impact on the residents' fuel poverty whatsoever or energy bills. And it also, the conclusion of our research and analysis of it was actually for them to do any further measures, they'd have had to take that wall insulation off and start again. And this just feels like, in terms of us doing getting good value for money and using resources efficiently, this is absolutely, it just felt like it was the most depressing thing. So having that long-term strategy, as Sarah says, even if you're only doing one step along the way, it means that each part of it adds up to the puzzle. And I think that's, yeah. Anyway.
And I'm assuming then if you follow that plan and you do the one step, and then if the decision comes later on that you need to retrofit another aspect, you're following, so it's having that increased value.
Completely, and particularly, yeah, that whole thing about the unintended consequences as well. This is where all of that is picked up. So you don't end up with homes that are where, say, you're kind of putting in cavity wall insulation, and the unintended consequence may be that the building is more airtight, but there's no ventilation. So you end up with loads of mold and really poor air quality. That all of those things can be avoided by setting out a strategy. So this is not about you know, kind of what your budget is now. It's about having making sure that each implementation is actually getting you to a better place.
Brilliant, thank you. We have a question from Ron. I think it was just maybe some differences in the presentations. He's just asking about to clarify the energy demand for heating. I don't know, Sarah, do you want to pick up on that?
Yep. So in Duncan's presentation, he was referring to the total annual energy demand for homes in Scotland. And in my presentation, I was talking about just the peak demand. So it's like at peak times, what does the grid have to supply? And I was looking at the whole of the UK. So there were just like two different metrics.
Brilliant. No, thank you. And Debbie has a question, and I suppose this is for myself and Sally, and how are the competency demand requirements determined to inform the training? So I think just Sally, do you want to pick up on that? In terms of, I think we're just looking at how the delegates are qualifying to meet the training requirements.
Yes, this is a there's been a lot of discussion over this. So first of all, the we liked the idea of getting a qualification at the end of it, and the Passivhaus tradesperson qualification is a really meaningful thing, and we know that it's kind of well regarded in terms of the output. So that was a good starter. However, we were really keen that the practical side of things, I cannot state how important that is for us, and really being able to apply the knowledge in terms of really deeply be able to look at a set of you know, construction drawings and be able to understand where there may be risks and really think about it in terms of what that's actually going to mean practically to apply it. So this is something where we used the Passivhaus Institute's kind of guidance in terms of the framework, but we also have very much looked at where we think the skill gaps are and where that needs to be kind of put in. And this is where, as I said, this is, from our experience, this is not necessarily aimed at everyone on site doing this kind of training. This is really about site supervisors and people managing teams, but actually we think that's where we have the biggest input. You know, we're talking about kind of the scale of the challenge and how difficult it's going to be, and this is very much a starter because we really understand that that time is precious, and we wanted to give something that was meaningful, but at the same time it wasn't going to be weeks of people's life that they needed to. So there is an expectation that after this people are going to have to work out how that integrates with their job. So this is not about telling them all of the answers, but it's giving them the mechanisms to work out what the solution should be. I don't know if that's kind of...
Yeah, no, that's brilliant, and I think you're right. From the kind of training that we did in the past with Sarah and Sally, that there is that wide range of delegates and participants from all ranges of the profession, and as you say, site agents, site managers. So one, Billy's asking, so if you're a clerk of works, what's the best training to go down? Is it the tradesperson certification, or is it maybe the Passivhaus designer? So what kind of training would be best for someone like a clerk of works?
I think start off with the contractor training, and then you may decide that you need more of a theoretical understanding of what's going on behind it. So you can do that level of interrogation. The designer course that we offer is actually modular as well. So some contractors have done the tradesperson qualification and then picked out particular sections of the designer course to kind of to bolster it and kind of to add on to their knowledge.
Brilliant, thank you. And Scott's asking, is there any training from the client's perspective? Scott, that's something that we can look at as well, and something that so if you maybe just want to drop me an email, we can sort of pick that up, and because it is something that's been raised quite a few times, so that we have understanding from the client's perspective as why we need to adopt this approach. Duncan, do you have anything that you maybe want to add into that? about
Yeah, I think that's crucially important. I think, and I wouldn't mind, Katrina, if you wanted to include me in that discussion. I think I think the client has to. I think fundamentally the client has to understand the type of product that they want to deliver and the reasons why. The technical part about what that means in terms of specifications on site is slightly different, but you have to look at the type of product and what are the outcomes that you're trying to achieve. And I think I'd be happy getting involved in discussions about how that's specified and procured.
Yeah, great. Thank you. And thanks for joining us, Duncan. And we've got a question for you. So how does Duncan feel the tenants will use the technology that is required for Passivhaus? What do you think about? I think
so when we talk about technology, we're talking about mechanical ventilation. So I think actually I would turn that question round in its head, because what we have in social housing, in fact, what I have in most of our homes are drafty, leaky homes, which people try to stop through closing vents and various different things. I think, if anything, mechanical ventilation would solve a lot of problems that tenants are trying to overcome themselves just now. And that's through no fault of their own. That's just an understanding of losing heat through air loss. So I think that mechanical ventilation set up well, commissioned well, implemented well, should actually take a lot of the pain out of managing that from a tenant perspective. I think it's actually easier than what we have just now. And I quite often go to homes where people have sealed vents, and that's not a situation that we want to get down.
No, definitely not. And I think this question is actually for everybody. So this person's working in building control, and there's a big push towards installing external insulation. And he or her is interested to hear people's opinions on how effective this approach will be kind of long term, and what issues may arise from it as well. Does anyone want to start with that?
Well,
it's a big question.
I know it is a big question. I mean, external wall insulation is a really good retrofit measure, because you can really improve the U value of the walls of a building doing that. But the walls of the building are only one element of the external building fabric. So when you're doing your external wall insulation, it's about having the plan. So you don't want to do your wall insulation and not do your windows, or if you're doing that, you're going to have to plan a way that the windows can be upgraded. If they're double glazed at the moment, you're going to want those to be triple glazed as part of your sort of zero carbon strategy for the building. So you need to plan in when the window work happens. You also have to plan in what's going to happen at the roof. Is the roof going to be being replaced in a later cycle, or are you going to be insulating within the roof space, and how does that junction work? And then again, at the ground, it's like if you're insulating and you've got a ventilated floor, how are you dealing with the ventilation? What's the plan for the floor? So it's an excellent part of the process, but each part is an excellent part of the process. Doing your ground slab insulation is great. Doing your windows is great. Dealing with your ventilation, fresh air is great. But it all has to be done with the whole plan in your mind, so you know which part you're doing and how all the connections work. Because I think, in a way, it's the same with like a new build building. It's like it's quite easy to work out what to do just through a piece of wall, but it's where the junctions come together, that the rigor that you get through Passivhaus projects is the interrogation of those points that makes the buildings perform without the performance gap. And it's like that with EnerPhit, but it's on a whole nother level, especially when you're looking at a step-by-step approach.
I would add to that this is exactly the kind of thing that is discussed in the training. So definitely, and the other part of it that's really core is we use kind of Passivhaus in terms of kind of slang for low energy building, but that doesn't mean that the application isn't applicable to other scenarios. So the kind of things that I was highlighting as creating performance gaps, and the kind of things that we'll be discussing in terms of the impact on site, all of that is relevant to every other building. And that's what's so important about this training, is that, so we've kind of used Passivhaus, but in terms of being able to assess kind of proposals that are coming forward, then it allows you to kind of question those things and kind of say, well, how have you thought about the impact on the ventilation, or there's a cavity wall here, is that actually, all of those things are kind of will come out of that it kind of broadens your mind to think about all of those other aspects.
Brilliant, thank you. Duncan, there's a question in regards to do you use PAS 35 2035 alongside the EnerPhit designs? Does this add value? What's your opinion around that?
I think this is one of my team. This is an easy one. So yeah, it's important. I think Sarah and I had this discussion yesterday. So it's important to understand that PAS 2035 is a process, not really a standard. PAS 2035 is about how you put things on a building and how you assess what you should put things on and when. So yes, we use PAS 2035 as a way, as almost an enhanced clerk of works version of how things should be applied. So, and for me, Sarah can maybe come in on this, but it's completely compatible with looking at a standard. You know, and the previous question is about how you put is insulation good against a wall? Well, yeah, it can be good and it can be really bad. I would suggest that PAS 2035 gives you a better chance of making it very good, because you have to mitigate or you have to avoid unintended consequences. So yes, PAS 2035 for me is fundamental. It's a good practice process that we should use on site towards an EnerPhit standard.
Brilliant, thank you. Sarah, did you want to add anything?
No, I mean, I think I agree. It's a process. It's not standard, so you need to tie in the standard to get the performance out. And the EnerPhit informed retrofit, the plan that we were talking about, you know, that can be used to form your PAS 2035 improvement options evaluation. And then again, it can be used as the basis for the PAS 2035 retrofit plan. So it fits in really nicely.
Brilliant. I'm not sure who's going to pick up this question, but Robert's asked, will you be looking at all construction businesses adopting BS 6001, responsible sourcing of materials, as well as PAS 2035, inclusive of circular economy in practice and through supply chains? And if yes, what's the timescale? So I think I can't remember who now, but someone mentioned like the product and the materials. Was that maybe?
Yeah, thank you.
Was that maybe yourself?
Yeah. So there's two things to say, just to give that some context on what I was talking about there is.
Yeah.
So when you are looking at the lifetime or the lifetime elements from an asset management perspective, managing homes, and you look at a 30-year business plan, if you're managing elements within the external envelope of that building, what we look at are the benefits of using things like aluminium and water goods. So we could use plastic, but plastic have a life cycle that's half the life cycle of the render and the roof. So the chances are, if you put a lovely new EWI and roof on it, you'll be out in 10 to 15 years and paying money to repair plastic goods. So we specify products that may be more expensive in the short term, but actually cheaper in an overall 30-year plan. So there's a specification for lifetime costs with that. I think, I'm not sure the chap's name, I think what you're alluding to is, will we as a sector have to start to look in a much more closely at the embodied carbon in the products we use? I think that's absolutely, and it's inevitable. There's no point in delivering an operational product that comes at a massive carbon footprint. So yeah, I think that's an inevitability of where we're going to have to be in the coming years.
Brilliant, thanks Duncan. Sarah, I don't know if this question is maybe for you. Is embodied carbon and optioneering of materials and processes considered at any stage during the Passivhaus programme?
So the Passivhaus sort of process is very much to do with operational energy. So its focus is on operational energy, because that is where the huge energy consumption currently is in buildings. Of course, once you reduce that down, embodied carbon becomes a much bigger sort of part of your overall carbon pie. And there is a tool called the pH ribbon, which can be dropped into Passivhaus calculations to do all your embodied carbon analysis. And we are working on a paper at the moment we should have out in the next couple of months that is looking at the full whole life carbon of a building regulation compliant building and a Passivhaus building to show where the embodied carbon sits. Because often you hear this argument, well, if you've got a thicker wall, there's more embodied carbon. But I mean, from the research which is now we've seen the research is completed, it's not ready to publish. but I was very pleased to see that the Passivhaus does extremely well, all on sort of all the metrics actually. And part of that is that the services needed to support a Passivhaus building are significantly less. And again, as Duncan was saying, the attention to detail that you have in the Passivhaus gets to what Duncan was saying with the specification of materials, in that the buildings are less likely to suffer from damage through mold and condensation and things, which requires a replacement cycle. So Passivhaus buildings, in terms of embodied carbon, tend to outperform building regulation buildings, even though you've got a lot of extra insulation and you've got like an MVHR system. But on the other side, you've got a smaller air source heat pump once we move to electrical heating, which makes a big difference.
Brilliant, thanks, Sarah. I think this is our last question, and it's around good practice guides. Is there a database that can be accessed on sort of past Passivhaus projects? And I think the Pacifiers Trust have a good database, don't they, Sarah?
Yeah, we've got. Yeah, there's in fact, because we did a launch for some retrofit masterclasses yesterday, so if anyone's on Twitter or LinkedIn, you'll see all kinds of links getting pinged around the last 24 hours. But if you go to the Passivhaus Trust's website, you will be able to see there's a case study page, so you can see all the retrofit case study projects there, and there's loads of information on the projects. And I think just in general, the whole Passivhaus community very open and sharing, and everybody just kind of wants to get everything done, so people are very happy to share knowledge and experience. So
definitely. And we have also on our Learning Hub website, we have immersive learning modules. Passivhaus standards have good case study examples, so we can send out the link to that people can access. So thank you very much. Sorry, go for it.
No, I was just going to say, from a client perspective, we're very keen to share anything that we're doing just now. I mean, this is something that we're all going to have to do. We're all going to have to improve what we deliver. So from any clients out there, I appreciate this is mainly construction professionals, but any clients would be more than happy to have a chat about some of the things that we do.
Brilliant. Thank you. Thanks, everyone. That was really excellent. Just to kind of round off and finish up, each month we'll be hosting a webinar on a different topic on EnerPhit, Passivhaus, and within the Retrofit family. So please look out for them and sign up to them. Please ensure that you're registered on the register your interest link. Danielle will just post it in the chat for you if you've not already done so, and then you can select which area in particular that you want to upskill in, or if it's all of them. But and we will then contact you with the courses available and the relevant dates that some of the dates that Sally ran through, and others. But please just be aware that some of the training has limited availability. And so just before we finish up, here's our final poll. So basically, what area of low carbon learning would you most value? Would be most value to you or your business? Passivhaus standards, EnerPhit standards, retrofit coordinator training, or basically an awareness of all of the above? Yep, so all of them. I think this is great and valuable, and Passivhaus standards, and then moving on to EnerPhit and retrofit. So brilliant. Just really excited about this programme that we're going to be delivering over the next year, and we're working with some great industry partners and training partners in collaboration. But really big thanks to Sally, Sarah and Duncan for supporting us in our low carbon learning journey. We hope this project has the desired impact that is to work towards a net zero built environment. And just remember what Sarah mentioned at the very beginning of the session, just thinking about that world that we live in, how it would look. So thanks everyone, and a big thanks to Danielle, the events coordinator, does all the technical work behind the scenes. So thank you. Bye everyone.
Thank you. Bye.
Thank you.
Bye.
Thanks very much. Bye.
That was brilliant. Thanks.